Okay, so we're told to consider the function f, defined by f of x equals 5 minus x squared for x less than or equal to 2, and mx plus b for x greater than 2. So this is a piecewise function, so depending on what x values we have different y values, where m and b are some real numbers. So those are just constants that we will maybe fill in later. So for part A, we're told to compute the derivative, d over dx of 5 minus x squared. So that's just going to be a power rule. So we're going to have then that dx, so the derivative with respect to x, of 5 minus x squared is going to equal, so that 5 is a constant, so its derivative is 0. And then when we apply the power rule, we're going to get minus 2x. So then it just equals negative 2x. So for part B, we're asked to compute the derivative in terms of constants m and b. So once again, we're taking a derivative with respect to x of mx minus b. So we're applying the power rule here. So that the derivative of mx is just going to be that coefficient to our x term m, and the derivative of b is 0 since b is a constant. And so for part C, we're asked to determine the values of constants m and b that make f continuous and differentiable at x equals 2. So to be continuous, we need the same y value, and to be differentiable, we need the same, we can't have a sharp point, essentially, is what we mean by that. So we would need to have the same slope. So the first thing we're going to want to do is, so we need slope to match up, and we need the y value to match up. So, well, we have the slope because we already computed our derivatives up here. So we're going to have negative 2x equal to m. And we're doing this for x equals 2. So we're going to have negative 2 times, times 2 equal to m. So m equals negative 4. So we know what m is now. And now to find our y value, we're going to want to set both sides of that equation equal to each other. So we're going to have 5 minus x squared is equal to mx plus b. Well, we're doing this at the value x equals 2, so we're going to have 5 minus 2 squared equals m, which we just found out was negative 4, times x, which is 2, plus b. So we're going to want to solve this for b. So we're going to have 5 minus 4 equals negative 4 times 2 is negative 8 plus b. So then combining things on the left-hand side, we get 1 is equal to negative 8 plus b. So plus 8, b equals 9. So our answers here are m equals negative 4 and b equals 9. And when we're asked to justify our response, I would just say something along the lines that functions must have same slope, must have the same slope. At x equals 2. So m equals negative 4, which is exactly what we did through our computations, but now we're just writing it out to explain and justify our response. So this is in order to be continuous, or sorry, in order to be differentiable. And then the other aspect of being differentiable is we need to be continuous. So then we can say that functions must have the same y value at x equals 2. In order to be continuous. So b equals 9. So here we're asked to just take the derivative of the following equations. So if we're told that f of p equals p to the 19th minus 1 of p, we want to find f prime of p squared. So for us, what that means is we're going to have that. First, we're going to rewrite f of p as p to the 19th minus, so anytime we have 1 over p, we can rewrite it as p to the negative 1. We can always just make that's like 1 over p to the 1 power. We can just make it to the negative 1 power and bring that p up to the top of our fraction. So then this just becomes a product rule. So then we're going to have that f of p is equal to 19p to the 18th minus, so we'd bring that negative 1 down, and it's going to become plus p to the negative 2, because we bring our exponent down and subtract 2. And since we're asked to find f prime of p, this should say prime here, sorry, f prime of p squared, what that's going to become for us is that f prime of p squared equals 19. So then this would be p squared to the 18th, but it tells us not to simplify, so I'm just going to go ahead and write it like this. Plus, and then this would be p squared to the negative 2. So for this next problem, we have that y equals x to the e minus e to the x plus xe. And we're asked to find dy dx. So once again, just taking the derivative. So the derivative of the left-hand side is going to be dy over dx. So now for that first term, xe, when we're taking the derivative of that, well, e is just a constant. E, just like pi is 3.14, e is 2 point something. So we're just going to treat it like the same way we would if there was any constant up there, but we're going to use the power rule. So we'll bring that e down. We'll have e x to the e minus 1. So bring it down, subtract 1. And then we have minus e to the x. Well, the derivative of e to the x is just e to the x, so it's going to be minus e to the x again. And then plus xe, so the derivative of an x with a coefficient is just that coefficient. So we just have the coefficient of x here is e, so it'll just be plus e. So for part C, we have that g of t equals 6t to the 7/3 plus 2 over t cubed minus 11. So what we're going to want to do is rewrite this function before we take the derivative. So we're going to get g of t equals 6t to the 7/3 plus 2. So here's what we really wanted to rewrite was this 2 over t cubed term. It's going to become 2t to the negative 3, because we can swing anything from the denominator up to the numerator by changing the sign of its exponent. So we were a positive 3 on bottom, and now we have a negative 3 as our exponent on top. And then minus 11. So when we're taking the derivative now, we're going to have g prime of t. So this first term, we're just going to use the power rule, and we're going to bring that 7/3 down. So it'll be 6 times 7/3. And then t to the, so when we subtract 1 from 7/3, it's like subtracting 3 over 3. So we're going to be left with 4/3. And then, so we want to take the derivative of the term 2t to the negative 3. So we're going to use the power rule again. We're going to bring that negative 3 down. So it'll be minus 6 t and subtract 1 from our exponent, so it'll be negative 4. And then the derivative of a constant is 0. So the derivative of 11 is just 0, so we're done. So for part D, we have the 4th root of x plus the 5th root of x, and we're asked to find dy dx. So what we're going to want to do here is we're going to want to rewrite our function y first of all. So y is equal to, so anytime I have something like this, I can rewrite it as x to the 1 over 4th power plus, so then similarly this would be x to the 1 over 5th power. So the denominator is 4 in this first term because we have a 4 outside the radical, and 5 in the second because we have a 5 outside the radical. And then the numerator is 1 in both of these cases because the power of x under the radical is 1. So now that we have it written this way, we're going to want to take the derivative. And so when we do that, we're going to get dy over dx equals, so we're going to apply the power rule. So we're going to bring that 1/4 down out front and multiply it. and then we're going to subtract 1 from the exponent. So 1/4 minus 1 is like 1/4 minus 4 over 4, so that's negative 3 over 4. And then this would be plus, power rule on the second term would give us 1/5, bring that 1/5 down, and then we're going to want to subtract 1, so 1/5 minus 1 is going to give us negative 4 over 5 power. And so that's your derivative. Another thing we're going to want to talk about, it wasn't on this exam review, but it will be on your exam, is the product and quotient rules. So the product rule is whenever you have dx of two functions of x multiplied together, that's going to equal f of x times g prime of x plus f prime of x times g of x. And sorry, I'm running into the other work. I was running out of room. So for example, if I had something like y equals x e to the x, and I wanted to take, or let's say x squared e to the x, and I wanted to take the derivative of this with respect to x, then I would get that dy dx is equal to, so first my f of x term would be my x squared, and my g of x term would be my e to the x. So x squared is just going to come straight down, and then we're going to take the derivative of g prime of x, or the derivative of g of x, which is just e to the x, because the derivative of e to the x is e to the x, plus, so f prime of x would become 2x, because the derivative of x squared is 2x, times g of x, which is, in this case, again, just e to the x. And then for the quotient rule, we're going to want to do, that's whenever you're taking the derivative of something that has this form, where you could write it as like f of x over g of x and taking the derivative of that. That will equal g of x f prime of x minus f of x g prime of x all over g of x squared. So if I had something like y equals we'll just go back to a similar example, just changing the position of the functions from before. We'll have x squared over e to the x. Here we would apply the product rule, or I'm sorry, the quotient rule, because we have a function of x divided by another function of x. So then, just following exactly what we just said, then we will get that dy dx equals, so g of x is just e to the x. F prime of x would be the derivative of x squared, so that's going to be 2x. Minus, so f of x is just x squared. G prime of x would be the derivative of e to the x, but that's just e to the x again, all over e to the x squared. So that's the quotient and product rules.